Hi guys, welcome again to my channel. In today's session, we will solve questions on paper 1, 2024. And as I solve this question, I will also walk you through the examination, the principal examiner report for this year as well, so that I will answer the question and tell you what candidates were doing wrong in the previous, those who wrote the exam, what were their shortcomings according to the examiner's reports, so that we can learn from these reports and not repeat the same mistake. Okay, because at times we may write some answers and think they are right. They may appear right, but they may not be sufficient to earn you some marks. So, which is the reason why I will answer the questions and also go back to the examiner's report to tell you what students have been doing wrong and how you can avoid repeating the same mistake. Okay, now let's start with question 1. Okay, question 1A. So the first question, complete the following description. A kibibyte has a dash prefix. 3 kibibytes is the same as dash bytes. A megabyte has a dash prefix. 2 terabytes is the same as dash gigabyte. When some students see the word prefix, they believe it is the first set of word before byte. Okay, before byte. So that is what some students always think, which is absolutely wrong. In this context, a prefix is not the leading word, but a prefix is a unit of measure. In this context, a prefix, a prefix, a prefix is a unit of measure. Okay, that what that helps to describe quantities, or multiples. So that is what a prefix means in this context. So a prefix in this context is not the leading words before the byte, but it is a unit that helps to describe the quantity or measure. So how do you describe the quantity of a kibi? That is binary. Okay, and how do you describe the quantity of a mega? That is denary. Is that understood? So don't write kibi or mega. So the answer for this is binary. So a kibibyte has a binary digit, while a megabyte has a what? A denary prefix. Is this understood? So 3 kibibytes, don't forget that 1 kibibyte is equal to 1204 bytes, which is also 10 raised power, which is also 2 raised power 10 bytes. Okay, so in this case, 3 kibibytes in this question should be equal to 3 multiplied by 1024. Okay, and that should be 3072 bytes. Is this understood? Now 2 terabytes is the same as 1 terabyte is equal to 1000 gigabytes. 1000 gigabytes. Okay, so that means that 2 terabytes is equal to 2000 gigabytes. So this should be 2000 gigabytes. I hope this is well understood. So now everyone should understand what a prefix is in this context. So the next question is to convert the denary number 241 to hexadecimal. Okay, now in doing this, we can use the long division method to achieve this. I think that will be much more easier. So 241 to base 16. So the first thing is to divide 241 by 16. But in your exam, you won't be using calculator. So you can do this way, 241 over 16. So 16 cannot divide 2, but can divide 24. So 16 times 2 is 32. So that means 16 divided by 24 can only be 1. Okay, then that will be remainder 8. Is this understood? That 16 times 1 is 16, then minus 24 is 8. Now 16 is 81, so you can do the multiplication that 16 times 1 is 16, 16 times 2 is 32, times 3 should be 48, times 4 should be 64, 16 times 5 should be 80. Then 16 times 6 is more than 81, so this should be 5, okay? So if you multiply 15 by 16, you should get 240. So that means the quotient is 15, remainder 1, okay? So 16 divided by 15 is also what? That will be 0, remainder 15, okay? So that means the 15 in hexadecimal is F and this is 1. So the answer is F1. So the calculation is not required, it's just 1 mark. I hope that is understood. So the next thing, state what is meant by an overflow in binary addition. So in binary addition, when you're adding two binary numbers, let's take for example, you're adding 1111 and 0001, okay? When these two numbers are added, 1 plus 1 is 01, 01, 01, 10, okay? If you take a look at this example, 4 bits are added here, 4 bits are added here, but the result is 5 bits. So that means this answer is too long, or it has exceeds the bit limit of the numbers added. So the last digit is the overflow, okay, is the overflow. So most of the time, this always results in an incorrect result in most of the time, because this overflow is discarded and only the number is left. And if you look at this number, this is an incorrect result. So that is what overflow means. So an overflow is is and is when the result or the answer exists in a binary addition, in a binary addition, and overflow is when the result exceeds the what? Exceeds the bit limit of the number being added. Okay, please don't mind my writing. My writing is too big because of the kind of pen I use. So if you write that in your own pen, it should contain that small space, okay? So in a binary addition, an overflow is that situation when the result exceeds the bit limit of the number being added. I hope this is understood. Okay, good. So let's move forward to question D. Computers use character sets when representing characters in binary. Complete the table by identifying the number of bits each of the character sets allocates to each character. Okay, so the character sets are ASCII, extended ASCII, and Unicode. So we are asked to write the number of bits that each of these character sets allocates to each character. So the number of bits for the ASCII is 7 bits. Okay, extended ASCII is 8 bits, while Unicode is 16 to 32 bits. So those are the number of bits each of these character sets allocate to each character. Okay. Now the next question, explain how the word clock is represented by a character set. So how computer represent this word clock? So the first thing is it takes the specific code for each of the letter. So let's take, for example, we want to use ASCII as an example. Okay, you know capital letter A is 65, right? B is 66, C is 67, and so on and so forth, right? Small letter A is 97, small letter B is 98, and so on and so forth. So for the word clock, okay, for the word clock, this is small letter capital letter C, small letter L-O-C-K. So C is converted to its specific code. So capital letter C is 67. So small letter L, if you follow this, would be, I think that should be 108. Small letter O should be 111. Small letter C should be 63. And small letter K should be 107. So the first thing is each of this letter is converted to its specific code. Is this understood? Then each code is now converted to binary, converted to its binary value. That is 67 is converted to 0, 1, 0, I think 0, 1, 0, 0, 0, 0, 1, 1. 108 is also converted to its binary. This to its binary. I hope you understand that. So each of them is now converted to its binary. So each binary is now placed side by side in sequence. That is, the binary for 67 is now 0, 1, 0, 0, 0, 0, 1, 1. The binary for L is also 0 something something. Is that understood? Up to the binary value for what? For 107. So all these are now placed side by side in sequence. So this is how clock is represented by a character set. Is that understood? Whether it's ASCII or extended ASCII or Unicode. So this is how it is represented. So in answering this question, okay, so first thing you need to write that each letter, okay, has a specific code, okay, then each decimal value that is from that code is converted into binary, and the values the binary values are placed in sequence. I hope this is understood. So each letter has a specific code, which the decimal value of each specific code is converted to binary, and the binary values are placed in sequence. So that is the answer to this question. So I hope this is understood. So now let's take a look at this examiner's report for question 1, because now we are done solving question 1. So before we go to question 2, let's look at the examiner's report. So key message: there is a need to use technical terminology correctly. Candidates should be aware that using a term inappropriately can completely change an answer. For example, it is not correct to say that because comprehension reduces the size of a file, the transmission speed will be faster. That is not true. Okay? Because the transmission speed depends on so many factors other than the size of the file. For example, maybe the network status, okay, and the internet speed. There are so many things that affects the transmission speed of a file. So to answer it correctly, you write that compression reduces the size of a file. The correct response is that because compression reduces the size of a file, the time taken to transmit the file will be what? Will be shorter. So time taken to transmit the file will be shorter does not necessarily mean it's faster. Shorter does not mean it's faster. If you have a good internet connection, it may be very fast. Okay? If let's assume you have a good internet connection and you want to transmit maybe 5 megabytes of data. 5 megabytes, let's take for example, may take 5 seconds. But if it is 10 megabytes, it will take 10 seconds. Do you understand? But the internet speed is still fast. So the only correct answer is the transmission time will be shorter and not faster. So I think these are common mistakes students make in the exam, because when you write, it may completely change the meaning of what you have written. It may make it incorrect, but to you it may be correct. So when you see your result, you start thinking, but I wrote the correct thing, why am I wrong? So at this level of study, some application of knowledge is expected. You have to apply knowledge, and candidates should ensure that they actually answer the question set. For example, if a question asks why lossy compressions would not be used in a given situation, credit will not be given for just a description, okay, of lossy compression with no reference to why it is unsuitable for the scenario in the question. So most students make this mistake. When you ask them to write an advantage, disadvantage, application, you see them writing the definition of that term instead of writing writing it to apply to the scenario given in the question. Okay, so most students do this mistake. So when you are asked to write why lossy compression is is not suitable. Write the reason why lossy compression is not suitable. Not just writing that lossy compression is when this, like a description, which is absolutely wrong. Okay. When the question requires some workings, when you are asked to work, for example, number-based conversion or low-level language program segment, candidates should make sure that their final answer is clearly identified. So when you're asked to show your working, make sure you show your working and make sure your final answer is different from your working. Okay? Candidates must ensure that they read the question fully and think carefully about their answers before beginning to write. If you look at while I was answering these questions, I did not just write the answer. I have to analyze the question before the answer was written. I did not just write because just writing may make me lose my marks. For example, some students will say kibibyte, the prefix is kibi. Instead of thinking that is this like an English of the first word before byte before writing the answer. So because they fail to think, they tend to write the wrong answer. So which is what you are seeing in that report. Okay. So let's take for example. So for example, if a question states that a range check is an example of validation check and asks for two other factors, no mark will be awarded if the candidate gives a range check as one of their answers. So some students do that as well. An answer has been provided in the question and you are asked to write two other answers. A candidate will tend to write the answer given in the question back and expect to get a mark. Okay. Now, this is a common mistake made by students as well. So in the instruction, if you go back to the instruction, most students don't read this instruction. And when they don't read the instruction, they just do whatever they wish because the instruction is not read. In fact, I can count most of my students don't read the instruction. They just go to answer questions and they may do things against this instruction. Look at the instruction states, use a black or dark blue pen. But you see some students writing answers with pencil instead of in a pen. You can even see some students using correction fluid. And the instruction says, do not use correction fluid. Do not write on the barcode. You see students writing on this barcode as well. Maybe rough work like I did here, writing some rough work. You see students writing on the barcode, which is absolutely wrong. Okay? You may use HB pencil for any diagram. So this is when you can use a pencil for any diagram or graphs. But you see students doing the other way. You see some students writing with pencil, then writing with pen on the pencil and cleaning the pencil. Some will not even clean the pencil. Okay, now imagine write with pencil, you've written, then writing with pen on the, maybe you wrote pencil, you wrote binary. So you see the students writing with pen on the pencil, then there will be what? There will be two markings there. Do you understand? So this is what the examiner is talking about. It says candidates should be very careful about writing their answer first in pencil and then overwriting in ink. Even after being erased, the pencil markings are still picked up in the electronic scanning. This results in a double image, which is very difficult to read. Can you see that? If an answer is illegible, no mark can be awarded. So imagine writing the correct answer and still getting 0 because you did not follow the instruction. Because the instruction never said write in pencil, it said write in pen. I hope you understand that. Now, planning an answer or writing a first draft should be first done either on a blank page or in the script or in an additional script of paper. In either case, the rough copy should be clearly crossed through. So don't write in pencil here in your answer space and then put a pen on top. No, you can do that in an extra sheet or additional page provided in the question. So these are common mistakes students make in the exam questions and during exams, and this affects them. It affects their grades. Okay. So now let's take a general comment on the question 1 we just answered now. The general comment on question 1 that has been answered. So the two calculations were usually performed correctly. Some candidates found completing the names for the two prefixes more challenging. So like I told you, some candidates will believe Kibi is they think is English language. That prefix means the first word before the actual word, right? So which is wrong. This is what the report is saying. This question was answered very well for question 1B. For question 1B, to convert to hexadecimal, both most candidates answered them very well. For question 1C, when you are asked to state what an overflow is, this question was not answered well. Many candidates gave insufficient statements, such as the answer is greater than 255. Who told you? Look at the example I made. The example is adding two 4-bit system. So this is not 255. This is not an 8-bit system. So how could you say the answer is more than 255? So the answer depends on that was why I said in the binary addition, an overflow is when the result exceeds the bit limit of the number bit being added. Bit limit of the number. So that means you have to look at the bit limit of the numbers. So overflow is as a result of bit limits of the number bit being added, not 8 bits. Some students believe that when the number is more than 8 bits, it means there's an overflow, which is not true. Okay, so this is now saying that the question is not well answered. Many candidates gave insufficient statement like the answer is greater than 255. This would be true if two binary numbers being added were each 8-bit longs, but there was no reference in the question to the length that was added. So the question never said 8-bit numbers were added. Okay, so the complete answer should cover all cases, no matter how long the original numbers were. I hope that is understood. Okay, good. Then for number GI, the answers were answered well. Okay, the answers most likely to be incorrect was ASCII character set, where some candidates put 8 bits instead of 7 bits. And for II, the answers were also answered well. Generally, the answers were answered well. The questions were answered well. So let's move to answering questions on question 2, so we can move forward from there. I hope this is well understood and you understand how to present your answer in each question, because if you don't present your answers properly, then you will lose the mark, even though what you write may be right to you, may be correct to you, but it may be wrong to the examiner, which is something I always tell my students. Okay, so let's move to the next question. Now, question 2. A photograph is stored as a bitmap image. The photograph has a resolution of 4,000 pixels wide by 3,000 pixels high. The bit depth is 4 bytes. Calculate an estimate of the size of the photograph in megabytes. So we are asked to calculate the file size, right? So file size of a bitmap image, the file size of a bitmap image, okay, is determined by the image resolution and bit depth. By the image resolution and what? And bit depth. So that means that the file size is equal to the image resolution, which is 4,000 times 3,000 times the bit depth, which is 4. Is this understood? So 4 times 3 is 12. 12 times 4 is 48. And this is times 10 raised power 6, right? So the reason this is 48 megabytes. If you don't write your 48 megabytes here, you might just get 1 mark, because it is 1 mark for the working and 1 mark for the final answer. So you must write your final answer separately. Is this understood? So you must be able to identify your final answer apart from the working. Okay, good. That has been solved. Now the next question. The photograph is compressed before being uploaded to a web server. Give 3 benefits of this photograph being compressed using lossy compression instead of lossless compression. For these two types of compressions, lossy and lossless, they are used to reduce file size, but they work in different ways. So for lossy compressions, from the word lossy, it means some part of the image is lost. Okay, while lossless means no part of the image is lost. So for lossy compression, that means that the reproduction of the original image is not critical. Okay, is not necessary. This is mostly used for web servers. Okay, mostly for web servers. So what are now the benefits? One, there will be a reduced file size. A reduced what? Reduced file size. The file size will be reduced. And when the file size is reduced, it means it will take a less storage space on the web server. So you can write that the file size is reduced, and or thus it will take a less storage space on the web server. Okay, on the web server. Is that understood? So the file size is reduced, thus it will take a less storage space on the web server. So don't just write reduce file size. So how is it in relation to web server? Because the question says the photograph is compressed before being uploaded to web server. So whatever you are writing must be reference to the web server. Is that understood? So we are writing the benefit of lossy instead of what? Lossless. I hope this is understood. Now for the second point, there will be efficient use of bandwidth. Okay, efficient use of bandwidth. Efficient use of bandwidth. What does this mean? That means that it will be faster to upload and download from the web server. Okay, so that means if you're writing here, you can write efficient use of bandwidth, meaning the upload and download from the web server will be faster. Because if you are using lossless, the file will be much more heavier than lossy. Is that understood? So which makes the upload and download slower for lossless. But for lossy, it will be faster. I hope that is understood. Now for the third point, the file will consume less data allowance. So the file will consume less data allowance. Okay, that is, it will consume less data during the transfer of file to and fro from the web server. I hope this is understood. So that has answered the question. Now the next question, explain how run length encoding will compress the photograph. So first and foremost, we need to understand what run length encoding is. So run length encoding is a form of lossless compression. Okay, first is a lossless compression. Okay, it encodes consecutive repeated values. Okay, it encodes what? Consecutive repeated values as a single value and the number of repetition. Okay, as a single value and the what? The number of repetitions. So that means if I have R A B A C A. So the consecutive means they must be occurring together. So that means this will be R A3 or 3A, B, AC, and how many A is this? 4 A's. Is that understood? So this is what it means. That is, the consecutive values are what? Are written as a single value and what? And the number of repetition. Is that understood? So how will it be now be used to compress this photograph? So that means that it will what? It will identify, it identifies the what? The consecutive repeating pixels. So look at the pixels are what? That are repeated consecutively of the same color. You know, color is made up of what? Of image. Is that understood? So it identifies the consecutive repeating pixels of the same colors. Is that understood? Then all this color is now saved as a single value. Okay, so it saves this color, it saves the color, that is each color, it saves the color, each color, okay, and the what? The number of times it repeats, the number of times it repeats. So which is exactly what I explained here, okay? So now I'm explaining this, I'm writing my answer in relation to the what? To the photograph, because photograph is made of pixels and all pixels has a color. Is that understood? So that question has been answered. Now the next thing is now saying, the question states, identify two elements of a bitmap image that can be changed to reduce the file size. Now we need to reduce the file size. What are the things we need to change to reduce the file size? So what we need to change is just the bit depth and the image resolution, okay? The bit depth and the image resolution. If you are not sure, remember when we calculated this file size, I said that file size of a bitmap image is determined. It's determined by what? By the image resolution and bit depth. So that means when you manipulate the image resolution and the bit depth, you get a what? A reduced file size. Is that understood? So that was why the question is, the answer is when you have to change the bit depth and image resolution. So these questions are questions on information representation of data from the curriculum. So after this has been solved, let's now take a look at the examiner's report on question 2. Okay, for 2A, an initial correct calculation for the number of bytes was usually seen. Some candidates should remember that if they then multiply by 8, because some candidates will multiply this by 8, instead of 4,000 by times 4, they also multiply by 8. So the report is saying that if they multiply by 8, they still need to divide by 8 to bring it back to bytes, because when you multiply by 8, it brings the value to bits. Okay, so you must divide by 8 to take it back to bytes, which is a common mistake some candidates made in the examination. Now for question B, for the web server. So you see what I said earlier when I wrote reduce file size, then you see the reason why it is wrong, okay? This was a question where candidates need to think carefully about the wordings of their answers, The question asked for the benefits of using lossy rather than lossless compression. So to simply state that the file size will be smaller is not enough. So writing reduced file size is not sufficient to get the right mark for that question, and it is not sufficient to answer the question. Okay, so when you write reduced file, it is not enough. That's what it's saying. It says so simply states that the file size will be smaller is not enough. This is a statement of fact, not benefits. So file size is smaller is just a fact, but you are asked to write a benefit, okay? A benefit would that because the file size is smaller than the lossless compression, the file type takes what? Less storage space on the server, and hence more photographs can be stored. I hope this is understood. So just writing a fact does not get you an answer. So you must think carefully before your answer is written. I hope you understand. There is also a need here to differentiate between the transmission speed of uploading and downloading and the time it takes to upload or download the file. The transmission speed depends on factor other than the size of the file. So when you're writing that about the transmission speed, so find a way to present your answer carefully so that it doesn't it doesn't translate to something else, and thus you losing your mark. So if you want to write reduced file size here, of course you know what you are writing, of course you understand what you want to write, and of course you understand the question. But unfortunately, your answer does not make a sense to the examiner. Your answer does not answer this question to the examiner. So you must be careful. Look at this. When I said efficient use of bandwidth, I said that meaning the upload and download from the web server will be faster. Do you understand? So faster does not mean that it will. Oh, I think that was wrong, right? Will be faster means I'm not supposed to write will be faster. I'm supposed to write will take less time. Can you see that? So I also made the same mistake. So that means whenever you're answering your question, you must be very careful. So instead of would be faster, you should have written that would what? Would take less time. Because faster means that there are so many factors that facilitate the speed of uploading and downloading an image or a file from the website. There are so many factors. So to be faster is wrong. Instead, you write will take less time. So now I've corrected my mistake. So please, guys, don't make that same mistake in the exam. I hope this is understood. Now, the third report from the examiner for question II for the one length encoding. Now, there were some good complete answers to this question. Some candidates need to ensure that they answer the question on the examination paper. Answer the question on the examination paper. Remember, when I defined one length encoding, I defined in this way that repeated is a lossless compression, encode consecutive repeated values as a single value. All this is just a general definition. But you are asked to answer it with reference to a photograph. So if you write this solution, you will not get your mark. I hope you understand that. Even though the definition is wrong, but you did not answer the question. So you must be careful when answering that. So it says that there were some good complete answers to this question. Some candidates need to ensure that they answer the question on the question paper. Responses describing the use of one-length encoding to compress text file with sequence of repeating characters were seen regularly. When the question asks about compressing a photograph, that is an image, no credit will be given to this level of study for answers about compressing text. I hope this is understood. So you must be careful when answering your question. Answer in context of the question. Don't just write a general definition or general explanation. I hope this is understood. Now, the next one, bit depth and image resolution. The question were answered very well. Easily the most popular corrected answer was bit depth and image resolution. And why is that? Because there was a preceding question where we are asked to calculate the file size based on bit depth and image resolution. So I hope this is understood. So we'll stop here on just information representation. In the next video, then I will solve questions on communication in paper 1. I hope this is well understood. Please don't forget to like this video and subscribe to my channel so that you can enjoy more content. Thank you for your time and have a good day.